Recursive algorithms. These are algorithms that solve a problem by reducing it to an instance of the same problem with smaller input. Recall, an algorithm is a finite set of precise instructions for performing a computation, or basically solving a problem. So for an example, we could give the recursive algorithm for computing n factorial. Say, this could be if n is equals to 0, the factorial will be 1. So basically we return 1. This will be the base case. Otherwise, we're going to return a function call. So that's why we have to give it a name. So if this is my function f, and this function f is the factorial, so I'm going to accept a value, an input value. So I'm going to return the f of what? So from the definition, you have the factorial of n can be expressed as the n multiplied by the factorial of the previous term, previous element. So this is now the recursive definition. So we could translate this into code readily by this one, n times f of n minus 1. As you can see, this is this is seamless in a way. The translation is quite seamless. So we could now immediately code this algorithm. So say you have f, so for the factorial, and I'm accepting an integer n. If n is 0, I will accept 1 or return 1, else I will return n times the f of n minus 1. And basically that's it. So the factorial of, say, we have 1, factorial of 2, 3, and factorial of 4. So let's call f and let's just f of 2, f of 3, and finally f of 5, just for testing purposes. Okay, so we don't need this anymore. Could try to run this one. Okay, so factorial of 2 is 2, 3 is 6, factorial of 4 is 24. The only downside with this approach is because the recursion has a tendency to loop to its function. For example, the factorial has a tendency to basically loop or recurse, and I don't think the loop is the correct term here, because it will be recursive, so it will tend to I think the arrow here is not quite correct, because for example, for a factorial of 4, it will be calling the function, going to its body, calling the function again, going to its body again, calling the function, going to the body, calling the function, going to the body, etc., until it will return the value to the caller. So this is basically expensive. Let's just illustrate this downside. What if we have a large number, like say, I don't know, maybe 10 or 100, something like that. Then if I compute this one, it cannot print it, so I need, maybe let's make it maybe 10. So here it's a bit instantaneous, okay, but this can be very slow. Say anyway, it's too large. So the factorial can be very expensive in terms of the function call in the stack, because here this will be stored in a stack, and if you continuously recurse, it has the tendency to slow down the code, increasing its complexity. So recursion is very easy to use, but again, we should be careful in using it. So basically that's it.